In this video, we want to integrate two integrals that will yield an inverse trigonometric function. Let's look at some of the formulas. Now the first one has this format right here, where I can write it in this form. The integral of du over u square root of u squared minus a squared, where in general u is going to be a function of x, and the a squared is going to be some constant. Say like 4, which is 2 squared, or 25, which is 5 squared, and so on. And then we look at the derivative formulas. Notice here the derivative of arctangent is 1 over 1 plus u squared multiplied by the derivative of u with respect to x. That formula I can use in the second integral. So for the first one, I'm going to look at this x to the fourth as x squared squared. And I'm going to let u equal to x squared. So du would equal to 2x dx. So let's transform this first integral into one involving the variable u. So I'm going to divide here by 2. So these would cancel out. This would be a 2 here. So x dx will be du over 2. But notice on this one I don't have an x dx. I have an x in the bottom. So let's do this. I'm going to multiply the numerator and denominator by x. So let's put an x there. And that's legal as long as I multiply the denominator by x. So x times x will give me x squared. Now that's the same thing as I started off with, because the x and the x squared will reduce to what I started off with. So then this is going to equal x dx is du over 2. So I'm going to put du over 2. I can write the 1.5 out in front. It's a constant. And then x squared right here, that'll be the u. And that's the square root of. Okay, so for the x to the fourth, I have it as x squared squared. But the x squared is u. So that's u squared minus 1. Now I have it in the appropriate form for the given formula. It was arcsecant. And this was absolute u over a. Notice here the a is 1 because 1 squared is 1. In the formula, this is u squared minus a squared. So in our case, it's going to be u over 1. And it's absolute u. Absolute u over 1. But remember, u is x squared, and that's always non-negative. So I can just leave out the absolute value on that one and write it as x squared over 1, which will stay x squared. And then the coefficient here is 1/2, or I can say it's 1, and it's 1 divided by a. A is 1. 1 divided by 1 is 1, and then I got the 1/2, so let's just make this 1/2. And it's plus the constant of integration. So a little trick we have to do here, multiply the numerator and denominator by x to get it in this form. And then to handle this x dx, we let u equal to x squared. And we have it all in the form we want it. And this is arcsecant here. Let me rewrite this. Again, it's arcsecant of absolute u. In our case, like I said, u is x squared, so it's going to stay positive, and that's over 1. So this just would be arcsecant of x squared. And again, plus the constant of integration. 1/2 arcsecant of x squared plus constant of integration. Now the second one's pretty straightforward. I'm going to let u equal to arctangent of x. Then du will equal to the derivative of arctangent is 1 over 1 plus the u. In this case, the u is x squared, and then it's times dx. Now I'll go back to the integral. I have dx over 1x squared right here. dx over 1 plus x squared. That's your du. And arctangent of x is u. So all I have here then is u du. Integrate with respect to u will give us a u squared over 2. And then it's plus the constant of integration. Now just go back to the original variable. U is arctangent. So we got arctangent of x, that's the u, and it's squared. So put this in parentheses, square, that's over 2, and then it's plus the constant of integration. Thanks for watching, we'll see you next time.